the b value, is inversely affected, is a reciprocal effect. So when the b value is 1, the period is 360 degrees, or 2 pi radians. But what happens when there's a b value, it's stretched by a factor of 1 over b. So if you saw number 2 right there, it would actually be a horizontal stretch by 1/2. It would bring it in a little bit tighter. So like horizontal stretches, there's a reciprocal effect to the b value. So the period starts off maybe as 360 degrees, but this horizontal stretch by a factor of b is actually a division of b. Or if you're wanting to do this in radians, you could say 2 pi is the original period, and it's reciprocally affected by b. So we actually eventually will stop talking about this period as a horizontal stretch and more of as a formula, and this will start to take on the meaning. So we'll look at one of these, and it's basically saying, what if we were given an equation, could we pull out all of its effects? So when we look at 3 sine of 4 theta, what's the amplitude? Amplitude will always simply be your a value as a positive, 3. And they can be very messy, 0.2. What is the period? Now the period, again, is not the b value. The period starts at 360 or 2 pi, but there's the b value. That's the effect. So I'm just taking 2 pi divided by b and saying 2 pi divided by 4 is pi over 2. It would take 90 degrees or pi over 2 radians to make a full wave. In degrees, if we were to do this, the period is 360 divided by the b value, which is 5, and 360 divided by 5 is 72 degrees. Not a nice number, but that's the period. And the last one in degrees, 360 divided by a tenth, gets a bit bigger, to 3,600 degrees to make one full wave. And you can imagine in your calculator, if you wanted to sketch that, your window would probably have to go from 0 to 3,600 degrees, and one complete wave would show up. So there's a quick part 2 about graphing by hand, and this is an important part about sketching. We are going to be doing something called 5-point sketching. So what I never want to see is someone typing in a function into their calculator, and it could look very, very complicated. So you might say, oh, 2 sine of 0.5 theta, and then saying, all right, let's graph this from 0 to 360 and see what happens, and then you try to sketch whatever you see in your calculator. Maybe you have to change your window settings, and it feels a bit frustrating. We're going to approach this a little bit differently. We're going to graph 5 points. The first point, last point, halfway, quarter way, and 3/4 way point. 5 points. And we're going to break things up into quarters. So in 2 sine of 0.5 theta, the amplitude is 2. The period is, in degrees, 360 divided by 0.5 is 720 degrees, which means when we're looking at 0 to 720, our first point is 0, our last point is 720. What I also know is that the amplitude is 2, 1, 2. I'm going to start drawing in a ceiling and a floor to say the graph must reach the top, it must reach the bottom, but never go above or below. So, first point, last point, halfway point, quarter way point should get to a max, 3/4 way point should get to the minimum, and that's it. These are 5 points which allow us to make a nice smooth curve, avoiding sharp jagged edges, a sinusoidal curve. Max is 2, min is -2, and this is drawing a 5-point sketch. First, last, middle, quarter, 3/4, done. We don't mess around. So there's a cos graph to try, and this one has a negative in front of it, and so maybe just for now we'll deal with this only as a positive because we are still just learning. So as a cosine graph, We have a similar bit of information to discuss. The amplitude is 2. The period is 360 divided by 2, which means the period is 180. So I know that we have our middle, we have our ceiling, we have our floor, and a cosine graph doesn't start at the origin, doesn't start at the middle point, it starts on the max. It ends at 180 degrees on the max. Halfway in between these, I'm not even looking at the scale, halfway in between, we reach our minimum. Halfway in between these, which is halfway between these, we are on the midline. Halfway between these, we are on the midline. Again, I'm not worrying about the scale. If I have my first and my last, I'm just dealing with the middle. And it looks like a giant V, but remember that a cosine graph almost makes kind of a C shape, just like the front, but this one is a little bit more compressed. And we could even make one more wave if we wanted after this, and it would just mean counting in another 5 points and sketching. Lastly, determine the equation of the following graph. So we start to be given the graph and we ask for the parameters a and b. I can look at this and say from the middle to the top, a is 2. Not so crazy. As a sine graph, I'm going to change this one. I'm going to change this as a cosine graph. So as a cosine graph, a is still 2. So we can say that a is 2. What is the b value? B value is the time for one complete wave converted to a b. So the time to go from here, maybe max to max, is if that's pi at the halfway point, pi over 2, then it's pi as one full wave. So if the period is pi, and we have an equation that says the period is 2 pi divided by b, we could do a little cross multiply to say I want the b value, which is 2 pi divided by the period. 2 pi divided by the period, which we know is pi, gives us a b value of 2. And this is an equation that would recreate this. So if you type this in your calculator, that's what you get to see. Tomorrow what we do is look at lessons involving not just vertical and horizontal stretches under the names amplitude and period, but vertical and horizontal shifts. Good luck.